Okay, so first thing I need you guys to do on this green sheet of paper is fold it in half like a book. This is one of the 2 foldables I do all year long. I'm not a foldable person. I'm not real good at them as far as using them in the classroom that much, but there are people that use a lot. I'm just not one of them. So fold it in half like a book, and then open it back up and fold the edges into the middle line. And I'll show you what yours is supposed to look like in just a second.
Fold the edges to the middle line.
So you end up with a little thing that looks like this, like a little booklet with 2 front flaps. Okay? Everybody got that? Okay, so you have like 2 little flaps that fold toward the middle, and you can open them up and you have the whole page again. Okay, this is going to be our foldable that we kind of are going over integers. Does anybody know what integers are?
Oh, numbers.
What kind of numbers?
The positive, negative.
Positive and negative. Okay, positive and negative numbers. So integers is just a fancy word for positive and negative numbers. So we're going to write integers at the bottom. So I'm going to split it up. I-N-T-E-G-E-R-S. Because I don't want to have to write on the spot where they come together. So integers across the bottom. So we're just going to review the rules a little bit. This side is going to be addition and subtraction. So what do you think the other side's going to be?
Subtraction.
We already did subtraction.
Multiply and divide.
Multiply and divide. So multiplication. And division. So get those labels put on there. Addition and subtraction, multiplication and division. Okay, so for the rules for addition and subtraction, we are going to sing a song. Y'all didn't know I was going to record you with the song. It's okay, I'm singing too. But before we sing it, you kind of need to know the words. So we're going to write the words down first so that you can see what you're supposed to say. So we're going to write the words here. I will sing it for you once, and then you're going to sing it back with me 2 more times. Just so that you can kind of get the rules in your head, not because I think it's the greatest song in the world. Okay, so the first line is same sign, add, and keep. And I'll explain what this means in just a minute. Same sign, add, and keep. Different signs, subtract. And then take, the sign of the highest value then you'll be exact. And just so you know, I sometimes write really fast, but it's because I want to move my hand out of the way so you can see. So don't panic if you're not writing as fast as I am. I'll pause and let you catch up, okay? And if you're not quite there and I move on, let me know. I'll slow down. Occasionally I get to going really fast and people need me to slow down. Okay, so this goes to the tune of Row, Row, Row Your Boat. So hopefully all of you know that song. That's the tune. Okay, here's how it goes. I'm going to sing it to you once, but then you got to sing it with me so that I'm not on this recording all by myself solo. All right, y'all help me out a little bit. None of your faces are shown. We won't say any of your names out loud. It'll be fine. All right? Same sign, add and keep, different sign, subtract. Take the sign of the highest value, then you'll be exact. That's how it goes. Okay? You think you can handle it? Do it with me twice?
Yep.
Okay, here we go. Ready? Same sign, add and keep, different sign, subtract. Take the sign of the highest value, then you'll be exact. Okay, good. Y'all did pretty good. Let's do it one more time. One more time, just to kind of get it in your head. Ready? Same sign, add and keep, different sign, subtract. Take the sign of the highest value, then you'll be exact. Okay, let me explain how this works. If they're both positive, you add them and keep it positive. You've been doing that since kindergarten. 2, positive 2, plus 3, positive 3, equals positive 5. You've been doing that for a long time. If they're both negative, negative 2 plus negative 3, you add them together and keep it negative. It's negative 5. All right, different signs, you subtract them and take the sign of the highest number. We're going to practice this with 4 examples. And I'm going to show you one other way to do it. So 2 plus 5, just write that down. I know you can do 2 plus 5, so 7 is going to be your answer. I do want to show you what I call the integer mat. It looks like this. We just kind of have a little chart with a plus and a minus. And I just draw little dots. You can use like little tokens. There's these little things we have that are yellow on one side and red on one side. And when you first learn integers, you might have used those. But I just do dots. I have 2 positives. So that's positive 2. This plus in the middle means that's a positive 5. You can circle it and make it go with that number right after it. So I'm going to do 5 dots beside that. If I have dots on top and on bottom, they cancel out. Do I have dots on top and on bottom on this? No. So does anything cancel out? No. So add them all together, there's 7 dots, right? So the answer is 7. What about if they're both negative? If I say negative 2 minus 5. Let's do our little, this is a negative 2, so I have 2 negatives. That minus 5 is the same as a negative 5. That goes with the 5. So then I have negative 5 more little dots. Do I have top and bottom dots?
No.
So nothing cancels out, so what do I have?
Negative 7.
I have 7 and they're all negative. So negative 7. Y'all see how those work? Those are pretty easy because they're the same sign. Okay, then we have negative 2 plus 5. Oops, sorry. Negative 2 plus 5. So I have 2 negatives. And then I have 5 positives. Do I have some on top and on bottom?
Yes.
Yes, and so they'll cancel out. What do I have left right here?
Positive 3.
3, and they're all positive, so it's positive 3. That's your answer. Or if you use the rule from the song, subtract them. 5 minus 2 is 3, and 5 is bigger, so take the sign of the bigger one, is positive. That's the rule from the song. So either way, you don't have to draw the little table. It's just showing you what's going on. Last one, positive 2 minus 5. So positive 2, that minus 5 means negative 5. 1, 2, 3, 4, 5. I'm going to cancel a few out. What will I have left?
Negative 3.
Negative 3. Okay, so this little math thing is nice to do for like small numbers, but what if you had negative 650 plus 518? Would you want to draw those dots? No, but could you imagine what it would look like negative, what did I say, 653, negative 653, positive 518. Do you know if your answer is going to be negative or positive? Negative 600 something, positive 500 something. Your answer is going to be negative, right? There's going to be way more dots on the negative if you actually drew it. Now you're not hopefully going to draw 600 and something dots. That would be a nightmare. But you can at least kind of visualize, oh, my answer has to be negative. Let's subtract. And it'll be a negative answer. Do you kind of see where I'm going with that? Okay, that's addition and subtraction. You can close that side. Let's do multiplication and division. These are a little bit easier, but there's no song, so it's not quite as fun. The song's going to be stuck in your head today. I'm sorry. Okay, so on multiplication and division, if they are the same sign, your answer is positive. No matter what. If they're both positive, your answer is positive. If they're both negative, your answer is positive. If they're different signs, your answer is negative. And there's a couple different little tricks to remembering these. I like the tic-tac-toe. I had some people yesterday say they used a triangle or a heart. So if that's what you like, draw it. I don't care what it is that you use. You pick it out. I'm going to do the tic-tac-toe right here. So I'm just going to make a big tic-tac-toe board. Like I said, some of you like the heart. So if you like the heart, use the heart or the triangle. Okay, so plus, plus, plus goes down the diagonal.
You're saying negatives.
And the rest is negative. And some people have seen this, but they have no clue how to use it. So let me kind of help you out on that. So I'll kind of show you how it works. The thing about the tic-tac-toe board is it doesn't matter if you go up and down. You can go down the column or you can go up the column. It doesn't matter if you go left to right or right to left. It doesn't matter if you go diagonally. It tells you what your answer is supposed to be. So if you multiply a positive times a negative, your answer is a negative. Or if I go backwards and I do a negative divided by a negative, my answer is a positive. You see that? Okay, so or if I go negative times positive, it's a negative. Negative divided by positive is a negative. Negative times a negative is positive. Any way I go, it's going to be right. So you just have to figure out which thing lines up with my problem of what I'm doing, and I can tell you whether it's a negative or a positive answer. Okay, it's a whole lot easier just to know the rules in your head, but sometimes we're so visual that we need something like this to kind of help us out, and that's okay too. All right, that's the integers. All I need you guys to do now is put glue on the back of that, and it's going to go down on the very first page in your journal like this. So that you have it when we take our integer test, you can use this. The very first page. Just glue it down. That's a label map. Okay, so get that glue down on your very first page. And I typically do not write on the backs of pages because we do a lot of gluing and we use markers sometimes. And it's hard to write, like if there's glue, it sometimes messes the paper, gets crinkly and stuff. You're welcome to do whatever you want, it's your journal. You have enough paper there that one journal will cover the whole semester, even if you don't write on the back. So it's completely up to you. All right, so flip the page. We are going to start our first unit. So we're going to do a title page, Unit 1. And the title of our unit is Functions. Unit 1 Functions, and I just did it in the middle of the page. If you want to do it at the top, it doesn't matter to me. You don't get a grade on these journals. You could get in trouble for not taking notes. Like I can give you a detention if you're deciding not to take notes in class. But I don't usually take the journals up and give you a grade. They are for your benefit, okay? This is a responsibility on you. It's something that helps you, and you get to use it for quizzes and tests, so it's really important that you're doing them. Plus, if you hear me say it, you see me do it, and you're writing it yourself, chances are you're gonna remember that about 85% better than any other time, because you're using more ways to learn. Okay, very first page on Unit 1 functions is going to be PEMDAS, or order of operations. So order of operations. And you don't have to write day 1 at the top, that's just something I use to keep up with each class. Okay, order of operations. What do you guys use to remember that usually? PEMDAS. Please excuse my dear Aunt Sally, right? So, PEMDAS. So P, E, N/D, A/S. There's PEMDAS. You've done order of operations probably since 5th grade, maybe 6th grade, somewhere in there. It's when you kind of started learning that there's a certain order you're supposed to do things in. 5th grade you might have done without the exponents or something, because I don't think you learned exponents until later. But you might have done that you had to do parentheses before you did anything else, or you might have started to learn that kind of thing. So P stands for parentheses, and I'll spell it because it's spelled kind of weird. Parenthesis is how it's spelled. I always thought it was weird that it was pronounced parentheses. So I'm going to put parentheses around the P. That just helps me remember that's what P stands for. What's E stand for? Exponents.
Then multiply, divide, and add, subtract.
That's right. Okay, so we're going to put a squared up there beside the E for exponents, because it's squared. I don't have a special little symbol for the last two, but that's okay. The M and the D go together. That's multiply and divide. And the A and the S go together. That's add and subtract. There's one big thing about those last two, though, that you have to keep in mind. Multiply and divide go together, add and subtract go together. The thing that you have to remember is go left to right. In other words, if all I have in my list are multiplication and division things, I don't necessarily do all the multiplication first, just because M comes before D in PEMDAS. I go left to right. If division comes first, then division comes first. I just do whatever comes first. Okay, does that make sense? And we're going to do it, I'll show you one that if you didn't do it that way, it would totally mess up the answer. So we're going to do 3 little examples. These are real basic examples. The first one, 2 plus 2 divided by 2 plus 1 times 3. These remind me of those things they put on Facebook and they say, like if it's this answer, comment if it's this answer, and there's always like 45,000 on both. So 45,000 people are wrong, okay, because they can't do PEMDAS. It kind of frustrates me, so I always just scroll past them because I don't want to see all the adults that are getting it wrong. Okay, so no parentheses, no exponents. I don't have to deal with either one of those. First thing that I come across is multiplication and division, right? So which one am I going to do first?
Division.
The division, because it goes left to right. So we're going to take care of this. 2 divided by 2 is 1. And then we can do this. 1 times 3 is 3. And then bring down everything else. And then you just have addition. Just go left to right. 2 plus 1 plus 3. And you should get, hopefully, 6. one. 4 divided by 2 times 3 plus, and then in parentheses, 5 plus 6. Close parentheses, yes. And y'all notice that I'm kind of using the old school symbols for things. The division is the line with the 2 dots. The multiplication is the dot. We won't be using those symbols in algebra much, but I want you to see it for order of operations today. The little division sign like that, you won't hardly ever see again. They're just going to use like a fraction bar or the slash. Okay, so I have parentheses, so we kind of need to do parentheses first, right? That's the first thing in PEMDAS. So 5 plus 6 is 11. So let's, I'm just going to rewrite this. Okay, so then I have 4 divided by 2 times 3 plus 11. Multiply and divide comes next. Technically the M is first in PEMDAS, but I need to go left to right. So which do I do first?
Division.
4 divided by 2. So 4 divided by 2 is 2. Now I multiply. 2 times 3 is 6. You should get 17 as your answer. If you, in your brain, insisted on doing the multiplication first, and did 2 times 3 first, then you have 4 divided by 6, which is 2/3, or 0.666667. Plus the 11, you're going to end up with a totally different answer than this one, and it's not going to be correct. Okay, we do get to use calculators this year, and if integers, if negative and positive numbers are something that you just really don't do well at, that's going to help you out a lot. If fractions are something you don't do well at, that calculator is going to help you out a lot. It's got that thing where you can use fractions on it. However, if you don't know how to do order of operations, you don't know what order to put them in the calculator, it won't help you. You have to know which order to type things in. So I can help you out on some things, but order of operations is one of those things you have to know how to do right. Okay? So that's those, oh wait, got one more example, sorry. And this one I'm doing because it's the exception to the rule. Five times 4 plus 1 times 15 on top, and 1 plus 2 times 3 on bottom. What does that big line mean? Divide. But can I look at that right now and divide it?
No.
That's impossible. So this one doesn't follow the rule, because technically I should be dividing before I add or subtract, right? But I've got to take care of the top, and then I've got to take care of the bottom, and then we'll divide. So 5 times 4 on top is 20, plus 1 times 15 is 15, all over 1 plus 6, because 2 times 3 is 6. Then 20 plus 15 is 35. 1 plus 6 is 7. Y'all are probably way ahead of me. You probably already did this, but hopefully you got 5. So just a refresher, this should be easy stuff. This is what we were supposed to do the first day, and I instead played a game with y'all. We got to know each other a little bit. Any questions on that? Okay, next page. The coordinate grid. And this is still review, but this is stuff that you actually are tested on and have to know about for algebra. So draw yourself a little grid like this. Nothing too big, nothing too fancy. We're just going to label it. I did notice when we did that pretest that a lot of you really struggle with naming points. I was kind of surprised, but the one that asked you to name what that point was, I had a lot of really random answers that weren't even close. So graphing must be something that a lot of people just really don't have a real good handle on yet. We're going to work on that. And if you do have a good handle on it, then great. You're probably ahead of some of your classmates. First thing I want to label is this dot right here in the middle. What's it called? I heard it. Who said it?
Origin.
The origin. It's called the origin. Anybody know what the word origin means?
Center, beginning.
Not the center, it means the beginning. Whoever said that?
I said
It was the beginning. The origin means beginning. So like if I say that you are an original, that means you're the first one to do that. That's what original means. You're the first one. So it's the beginning. That's why we always go back to this point when we're counting, when we graph. You always start at the origin, because starting at the beginning is a great place to start. Alright, there's 4 quadrants, which the prefix quad means 4. So there's 4 of them, and they go counterclockwise, which is kind of weird. But who knows, that math person way back when thought that was cool. So this is quadrant 1, and you can write it with regular 1. It doesn't have to be Roman numeral. This one's quadrant 2. This is quadrant 3. And this is quadrant 4. Couple ways you can remember the order. I know some people have been taught that it's a coordinate grid, so it starts with C. If you write the letter C, you start in this top little corner, you work your way around, right? So that's one way to remember it. It starts at 1, 2, 3, 4, like that, goes around. That's one way. The other way is if you'll look at my clock back there, the 1 is in the top right corner, correct? That's where the 1 is. The 4 is in the bottom right corner. If you can get 1 and 4, hopefully you can get 2 and 3 in the right spot. Hopefully you're not counting 1, 3, 2, 4. Okay, I'm assuming you guys can do that. So, couple different ways. Look at the clock, make the letter C, something like that. But just know it goes backwards for some reason. We have the x-axis, which is this line. When I was learning these, I remembered that was the x-axis because it went across, and an x crosses things out. So it goes across. The x goes across. And then the y-axis. And a y kind of looks like an arrow that goes up and down, but somebody took it apart and they put the arrow the wrong way. So that one helps me remember that the y goes up and down because it sort of looks like an arrow pointing up and down to me. I always try to figure out ways to remember things that I can connect in my head because, I don't know, that's just how I remember things. I don't know why. And I think it'll help you if you'll do that. Okay, last thing are what I call quadrant faces. Everything in this quadrant is a positive and a positive, so this is a super happy face, like the party face is in that first quadrant. Positive, positive. I think they look like faces, that's why I call them that. This one is a little mischievous or having a little bit of a bad day. This one's negative and then positive. Or maybe it's winking at you, I don't really know. Quadrant 3 is all negative. Quadrant 3, they just gave up and took a nap. Like they're done. It's all negative. Quadrant 4 is positive, then negative. And that's just labeling it. Nothing too fancy, nothing too special. We have 4 vocabulary words, and then we're going to start cutting stuff out of the papers that I gave you. We'll glue stuff down. So our first vocabulary word is scatter plot. Hopefully you talked a little bit at least about scatter plots last year.
We did.
Once we get to them, you'll probably remember, oh yeah, we did do that. Scatter plot. And I do really short definitions, so we're not writing like a giant definition. Scatter plot is a graph of points that represent data, or data, depending on how you like to say it. A graph of points that represent data, or data. Not a dot to dot, they're not connected, it's just a bunch of points. The goal of a scatter plot is to look at a bunch of stuff and figure out what is the trend, what's the average, what are most people doing. They use these in sporting statistics, so those of you that are in sports, scatter plots are used a lot. Anybody in here play basketball? Okay, so have you ever seen the sheet that the basketball, usually the manager has to fill out that marks exactly where you shot from and whether it was made or not, and they circle it if it's made? Y'all know what I'm talking about? It's like a sheet. That's kind of like a scatter plot. They're tracking where you shoot from and whether you make it. So if this person shoots from right here and every single one of those is circled every single time, we need to give them the ball when they're there. That's a trend. That person is hitting that shot every time. They do it in baseball, football. They do it in all kinds of sports. They do it in marketing and in business. What, have y'all heard about the iPhone 6 coming out?
I'm good.
Okay, what's so special about the iPhone 6 that they're really talking about a lot?
No.
Anybody in here know?
It's big.
It's bigger. The screen is bigger. I guarantee you they looked at data, and people are buying the Galaxy S5, and people are buying the Note whatever 3, is it 3? I don't know. The Note, they're buying all these other ones, but the screens are gigantic. And the iPhone people are like, oh crud, we have a tiny little phone. All these people, the trend is they're spending a lot of money on big screens. iPhone better step it up and make a big screen. So this new one's coming out, they're gonna have a big screen on it because they've looked at a plot of points and it has all these points that say people like the bigger screen phones. So iPhone's taking that into consideration in marketing. So they use it for a lot of stuff like that. Okay, correlation is the next word. Correlation describes your data. And there's only 3 options. You got positive, you've got negative, and you've got none. That's your only 3 options. Positive would be the temperatures are getting hotter and hotter and hotter for the summer, so the snow cone sales at the snow cone stand go up and up and up and up. So temperature goes up, snow cone sales go up, right? Does that make sense to y'all that they're gonna sell more snow cones if it's hot outside? If the temperature goes down to like 19 degrees, what's gonna happen to snow cone sales? It's gonna go down. They go the same direction, both variables. If they're going in the same direction, that's a positive correlation. Okay? Negative correlation is athletes that are in professional sports, say basketball or baseball. The older they get, the less playing time they usually have. Now, there are a few people that are exceptions to that rule, and we'll talk about that in a sec. But the older that most athletes get, the less they're going to play. Football players, the older they get, the less time they're on that field. Baseball players, you don't see too many of them, you know, that are that old, that are still playing and still playing at a decent level. Basketball, Dirk is holding it down, but he's kind of starting to slow down a little bit, and I'm not sure how many more years he'll have. He'll start to dwindle as far as how many minutes he has on the court. So that's a negative correlation because one is going up, their age is going up, their time playing is going down. Or, and this one isn't one that I would suggest anyone do, but the faster I drive, the less my time is to get to school. So my speed goes up, my time to get here goes down. How long it takes me goes down. That's opposites. Y'all see that? If I drive super, super slow, my speed goes down. It's gonna take me a lot longer to get here. So that's opposite, that's negative. No correlation is if I say your age and your eye color. It doesn't matter if you have a birthday, your eye color is not gonna change. Correct? Or if some way you could magically change your eye color, that's not gonna make you older. So that's none. Trend line. Oh, I don't know why I skipped 2 lines, but that's okay. Trend line. Trend line is the line that best fits the data. This is the average, so put the word average in parentheses. It's like the average of all the points. You have all these points all jumbled together and kind of draw a line between them all. So that's the trend line. You'll hear me say line of best fit a lot, because that's how we used to call it, so it's the same thing. And then the last one is called outliers. This is a point that doesn't fit the data. This is your Dirk Nowitzki. This is Nolan Ryan, or who? Okay, yeah, or it's just these people that play and they're way older. That's the outliers. Or I'm trying to think of who else. Derek Jeter, just retired. That's a good one. Derek Jeter. Football, we had some. Brett Favre. We thought he was going to retire like I don't know how many times. He finally did. I mean, but things like that. Reggie Bush, I think, played for a really long time.
Is he retired?
Yes. But those are outliers. Those people don't fit the norm. Or what about somebody who's really tall but has tiny feet?
That boy in that picture?
Okay, but I don't think his feet are tiny.
Oh.
Yes, that guy in the picture is 7'1", but he I think wears like 17-foot shoe, or 17 shoe. But I had a friend in high school who was ended up being a ballerina. She danced ballet. She was almost 6 feet tall, and she wore a 5.5 size shoe. So her feet like almost didn't exist. It's a good thing she had great balance and could walk on her toes, because that's what it looked like she did all the time. Her legs just kind of went down, and like no foot hardly sticking out at all. And she was super tall. So that's kind of an outlier, or somebody who's really, really short with really big feet. They look like a corner. Okay? So that's an outlier. That's not the norm. That doesn't usually happen. All right, so what I want you guys to do is the papers that I handed you that looks like this. Cut out the 3 little graphs at the bottom, but keep them together. You don't need the words that are underneath it. You just need the 3 little graphs. And you're going to glue those down to the bottom of your page. If they'll fit, and if they won't, go to the next page. Time to get that glued down. Remember that today's is a little bit longer than normal because we're doing 2 days worth of lessons. So usually I won't be up here talking quite this long. Just glue it down at the bottom. Put those 3 little lines under it so that we can identify these. Okay, what we're going to do is look at these and we're going to figure out where the line of best fit is, first of all, where the trend line is, and then we're going to decide what kind of correlation do they have. So on the first one, if I was drawing the line of best fit, it would kind of go like that. Now mine may not be exactly where yours is, but they should be pretty close. They should at least be angled the same direction. Okay, this is one of those things that yours can be a little different than mine, and it's okay. So draw the line of best fit on yours. What kind of correlation is that?
Positive.
Positive. It's going up, right? To the right. So this is positive. And that means both variables increase or both decrease. Go down. Either both of them are going up or both of them are going down at the same time. That's what a positive correlation is. They have to be moving the same direction. This would be like the snow cone sales in the summer or in the winter. Because in the winter they go down and the temperature goes down. It'd be cool if we lived in a place where we could buy snow cones all year round and the temperature outside wasn't really, really cold. Okay, the second one.
Negative.
It is negative. Your line of best fit's kind of like this. So this one's negative. One increases or goes up. One decreases or goes down. Let's go ahead and draw an outlier on this one just so that we can label it. So just draw you a point that's somewhere off away from the rest of the points. And draw a little arrow to it, and that's your outlier. Or if you want to write Derek Jeter beside that, or Dirk, or whatever, you can do that. So that you'll know that that's somebody who doesn't fit the norm. That's the outlier. All right, what about that last one?
No.
There's no correlation. I'd have to draw like a spiral or something. It wouldn't work. So this is none, or no correlation either way. And just to let you know, if it's completely horizontal, that's also none. If it's completely vertical, straight up and down, that's also none. What that means, that's kind of like the eye color versus your age thing. Your age still increases, right? What happens to your eye color? Stays the same. It doesn't matter how old you get. Your eyes don't change colors. That just doesn't happen. So it's going to stay the same. So that is when one is staying the same no matter what the other one does. Okay, next page. Hopefully last page. Cut out the last little graphic all by itself. So it looks like this. And that's going to go way at the top of your page so we'll have room for everything on this page. The one that says age of car at the bottom. Age of car. Once you get it glued down, go ahead and draw this trend line. Kind of where you think that line of best fit would be. I'm going to draw it right about there. And go ahead and extend it all the way across, even though there's not dots down there. And I'll explain to you why you do that in just a second. Draw the line of best fit, you're kind of dividing all the dots up. Half of them on bottom, half of them on top. Just estimate the best you can.
Wait, did you want me to glue this on the back page or the?
It's up to you. If you want to do it on the back, that's fine, or if you want to do it, I don't write on the back, but that's completely up to you. Okay. What kind of correlation do we have here?
Negative.
Negative correlation. Spell the whole word out. Where's the C-O-R-R? This is talking about the age of cars versus how much they're worth. So negative correlation, what does this graph tell you? What's that graph telling you? If we're talking about the age of the cars and how much they're worth. Go ahead.
The price goes down as the number of the car gets up.
Okay, so as the car gets older, what happens to the price of it or the value of it? It's going down. So what this graph is saying is older cars are worth less money. Now, is there an exception to that rule?
Yes.
Okay, what would you think? I know several of you are like, wait a minute. What would be an exception? Tell me an exception.
69 Camaro,
That's what I was-
67 Mustang, the fastback Mustang.
There we go. We got somebody who likes cars in here. Okay, so if you have a classic car, 69 Camaro. You know, the price is not going to be anywhere down here. It's going to be way up above some of these others. Okay, so classic cars, it's gonna eventually go back up. Now, maybe they're only studying Kias, I don't know. Okay, but this particular graph is saying the older they're getting, the less they're worth. And typically that's usually about what it runs, but there's certain vehicles that that's not true for. So they're gonna ask you questions like, how much for a 4-year-old car? I'm not gonna write the word car, but you're gonna know that that means car, not for a 4-year-old kid, just a car. Okay, so based on this graph, if I was buying a 4-year-old Kia, because we're not talking other things, based on this graph, how much do you think I would be paying for a 4-year-old Kia? Now here's the key. Don't look at the dots, look at the trend line. Because you're looking at the average, so about what?
10,000, 11,000.
10, 11,000, so it depends on where you drew it. Mine looks like it's right at 10, but yours may angle a little more like that, so it may look more like 10, 11 or 12, and that's okay. Or it may angle more down, it may look more like 7 or 8. But somewhere around 10, we'll just say about 10. When they give you a question like this with multiple choice answers, I guarantee you 15,000 is going to be one of your options, because 15,000 is one of those dots. This is really close, so that one they probably won't do, but this one they might do 6,000 as one of your options. Be careful, it's the line, not the dots. You're looking for the average, not all the different ones. Okay, on average, what do you think you would spend? Okay, so now we need the last graph and chart. So it's this one that has like all the years, and I had to cut mine apart to fit it on the page, but you might not have to. It's just how I write really big too, so just depends. And while you're cutting that out, I'm just going to talk about it a little bit because I find this one really interesting. This is a chart of data about the millions of people that get the newspaper, like the Dallas Morning News, compared to the millions of people that have TVs in their house. Okay, for y'all, it's not that interesting because you don't know very many people that don't have TVs. In fact, you have TVs on your phones now. But my dad graduated in 1963, and his senior year was the first time they got a TV in their house in 63. So there's a lot of people that didn't really have TVs in their house until probably the early 70s. When you can see the jump from 1950 to 1960, that's a huge jump. 4 million people to 46 million people. I'm assuming this is only in America. I don't really know what this is, but I mean that's a pretty big jump. What we're going to do is graph this and see if there's a correlation. In my mind, my thought is, if you're getting your news from the TV, you probably aren't going to buy the newspaper, right? So that was my kind of thought process, and we'll talk about whether that was correct or incorrect, and how that fits in once you get these glued down and we can graph them. The newspaper circulation is going to be your X numbers, the top row. The television sets is going to be your Y numbers, the bottom row. So you might want to label that on that little data table so that you'll know which ones are X's and which ones are Y's. And that just makes it easier to graph. There we go. Now we can see more. Cameron, can you see okay back there? Okay. I had somebody the other day that said they were having a hard time. I didn't know if I needed to rearrange my room or something. Okay, so the very first dot, the very first point I need to graph is 54, 4. So I go over to 50. I kind of estimate where 54 is going to be. This is kind of an estimation. and I go up to where I think 4 would be, so this is gonna be kinda like right here. Not exactly the middle of that box, but close to the middle of that box. So for those of you that like exact, I'm sorry, this is estimation on this one. Throws the OCD people off a little bit, but that's okay. We'll survive. 59 and 46, so go over almost to the 60. And now you get to go all the way up, it's a pretty big jump, to 46. So 10, 20, 30, 40, 6. Thanks. Okay, the next one. 62. And up to 59. So almost to the 60. What's the next one? 62 to 76, so it's kind of on that same vertical line. 62, not 70, but a little bit past halfway, so it's kind of on the same vertical, right up there. And then I have 62 again, all the way up to 92. And then the very last one is 55, so halfway, and 101, so just above the whole edge of the graph. There's my points. Where would my trend line be? What'd you say?
Up and down.
Straight up and down, right? Vertical line. So straight up and down. Kind of like that. And what I tell you that is for correlation. No correlation. Which means no correlation. I don't know if you can read my, went off the page a little bit. Which means that it doesn't matter if they have a TV, the same number of people are still getting the newspaper. Brainstorm a little bit. Why do you think they might still be getting the newspaper even though they're probably getting their news from the TV? What other reasons would they get a newspaper? Crossword. What else? Horoscope. The comics. What's on Sundays that some moms really like? Coupons. Tons of coupons and ads. Classifieds. You can't exactly turn on your TV to channel 4 and get the classified ads. Right? So that's probably why my theory was wrong, because maybe they're not getting the newspaper for the news. Maybe they're getting it for all those other things. You know? And they're using TV for the news, but the newspaper they use for all kinds. It has the stock market report. It has recipes. I mean, you're not going to get all that on TV. You can't like pull up your TV and see a recipe and go cook it in your kitchen. You can watch somebody cook it, and then you have to look up the recipe. You see what I'm saying? So this one's no correlation. All right, that is all the notes. Let me turn this off real quick.